you have discussed about Amazon services, Amazon facilities available with respect to computing cloud, storage cloud, and various facilities provided with respect to storage through Amazon Web Services. So today we shall continue our discussion with respect to Google App Engine. In this chapter, we will be discussing one more major player, Microsoft Azure. Let us see both of them in this session. Okay. So Google App Engine. Google App Engine is a platform as a service implementation. It is a distributed and scalable runtime environment that provides Google's distributed infrastructure to scale out applications. The core concepts and architecture will be seen here. Application lifecycle also will be discussed. Cost model as well as observations are seen. So first of all, we shall see architecture and core concepts. Infrastructure, runtime environment, storage, application service, and compute service. As we have seen in the previous sessions also, Amazon also was explained about how infrastructure is provided, what are the how runtime environment is provided with respect to different operating systems, and how storage services are provided through S3. We have discussed simple storage service in Amazon. Similarly, how Google gives the facility need to be seen. Application service also need to be seen, and then computing facility through Google facility we need to discuss. Okay, so here in the infrastructure, App Engine hosts web application and its primary function to serve users' requests efficiently. Here, as Amazon Web Services, here also in Google, it is also web service which will provide all these facility through internet. As we have already started working with the Google Drive, because we are, this is also one example which we are using Google Meet, Google Drive, Google Office facilities like Google Write, Google Photos, Google Presentation, all these facilities which we have started using with Google Drive is the example where you can understand all these facilities are provided through internet. So App Engine's infrastructure takes advantage of the many servers available within the Google data center. Let us move on. Okay, so here this is the core concept shown in this picture. There is a web application, sandbox, runtime environment will be there. So there is a development, there is a local machine. We have seen this similar implementation with respect to a cloud. Same with respect to Google, how it is being represented is shown in this picture. So in the there is a development, there is a local machine. All these are developed through Python. Some of the implementation are through Java also. Okay. And there are multiple web applications available to run these web applications. You need to have a runtime environment that is also embedded here. There is a data storage. There is a URL fetch, because how HTTP requests and HTTP responses are being executed through Amazon Web Services, which we have seen in the previous session. Here also, URL fetch itself is a big function here. An image manipulation. There is a task queue. So many tasks will be there. It will be maintained through a queue. There is a cron jobs, because at a particular point of time the programs or the jobs need to be executed. That also can be scheduled here. All this infrastructure, this picture shows you the platform for App Engine. There is a runtime environment available. There is the App Engine infrastructure available. So through this, you will be able to do all transactions. As I told you, for each HTTP request, it locates a server where the required information is available, and then that information will be fetched from that server, and it will be shown to the client. It will be sent to the client. So HTTP request locates the server hosting the application processing request, evaluates their load, and if necessary allocates more resources, or either in the time of fetching or in the time of storing the data, this operation will be performed. So you need to know that. For this, you must have a proper runtime environment to do this operation. The runtime environment represents the execution context of application hosted on App Engine. With reference to the App Engine, infrastructure code which is always active and running. So the runtime environment, as you know already, until doomsday, the application program execution need to be always in the waiting mode, so that any request comes and that need to be executed. That should be obliged. Any request comes, that should be served, that should be understood, and the proper data need to be, so either it should be stored or it should be sent back to the client. This is what something like you're using a searching in Google. Even 24/7. You can easily get the information whenever you want. So that program will be running in the background. So which is always active and running. Runtime codes into existence when the request handler starts to execute and terminates when the handler completes its execution. Okay, so let us move on. So in this App Engine's infrastructure takes advantage of many servers available in Google data centers. I wanted to add one more point here. There are multiple data centers available. There are multiple location data centers available. As we already said, at least 3 copies of the data will be saved in various locations. To avoid fail-safe, or to avoid fault tolerance, to provide fault tolerance. It should fetch the data from various locations, and then it should be compiled, and it should be sent back to the client. So for each HTTP request, App Engine locates a server hosting the application that processes the request, evaluates their load, and if necessary allocates additional resources if required, or redirects the request to an existing server. Also responsible for monitoring application performance, collecting statistics on which the billing is calculated. So here again, because it is a subscribing mode of execution, so that's why it is being calculated. As I can give you an example here. We have taken a Google Suite facility for our institution. So this facility given to an education institution, which is a government institution, and the limitations are there. So you can use at maximum, you can have 100 users at a time for one meeting. Because of that only you are able to use this facility, and we are able to give you the classes like this. Okay, all these are being recorded. It is being stored. It is in the cloud. So this recording, whatever the class recording, it will be stored in the Google Drive. Okay, as a recording, it will be saved. Your attendance will be saved in the cloud. So, and billing calculator. Suppose you wanted to have, now currently we are restricted to 100 users. Suppose you want to have 300 users, 400 users, so you need to do some subscription. So then correspondingly, all these statistics need to be calculated, collected, and billing need to be done. So for that, this infrastructure will support that facility. Okay, next, runtime environment. So as I told you already, to execute any application, you must have a proper runtime environment. For example, suppose you want to use a Java application in your system, you must have a Java server. That's what here supported runtimes available here. Okay, so we call it a JRE, Java runtime environment. That should be available in your system. Then only you will be able to execute Java program. Similarly, so the runtime environment is very, very important, which you have studied in your compiler design also. Where once you have started learning syntactic analysis, semantic analysis, later how runtime environment, how stacks will be implemented and how stacks will be used, how heap will be maintained. All these are the facility of runtime environment. Runtime environment is an environment which helps in executing your application. So supported runtimes available are Java, Python, and Go. Currently support Java 6, Java Server Pages, and applications interact with the environment by using Java Servlet standards. So these are the basics of any architecture if you are thinking about. Similarly, you can go through any other cloud service provisions and then what are the facilities available from that, and then you can get more information and you can implement some projects in it. Next, storage. About storage, App Engine provides various types of storage which operates differently depending on the volatility of the data. There are 3 different levels of storage: in-memory cache, storage for semi-structured data, and long-term storage for static data. See, while saving the data, also think. See, if you want to have a high-speed memory, then you can go with a memory cache. Suppose you wanted to store data in a proper, semi-structured data. It's not a relational database model like a structured data need to be. So semi-structured data, like a stream of data comes. How to store long-term storage data for static data. Static data is normally it will not be volatile. For a particular period of time. So such data need to be saved as a long-term storage. Okay, so there are multiple ways of providing this facility in storage servers. Okay, next we have a static file servers. Static file servers. Static file servers is something like to save static data. As we said, say for 1 year the data will not be modified. Maybe one month data will not be modified. At least for 48 hours data will not be modified. Like that, if you can think of some information which are think about it is a static, then no need to go with. So you can think of static file servers. These file servers are optimized for serving static content, and user can specify how dynamic content should be served when uploading their applications to App Engine. See, I can give you static data and dynamic data in a better manner. Like suppose you have developed a website. Okay, suppose you have written your web pages using simple HTML, CSS, and PHP and Perl coding. Okay, so these are considered to be static. Whatever you show, that will be static. For example, here the PPT is static. Suppose in the PPT, suppose you are generating, depending on the time, depending on the request, you are generating your data, then it will be dynamic content. So, for example, Drupal, okay, Joomla, these are all web service content managers. There it will create the data dynamically. So dynamic content will be created. Static data constitute of components that define the graphical layout of the application: CSS file, plain HTML file, JavaScript file, images, icons, and sound files or data files. This is what I was mentioning. Suppose you create a simple, straightforward raw file for your web page. You need to use a CSS, cascading style sheets, HTML pages, JavaScript files, images, icons, and sound files. These are all static data. Okay. Data storage. Next is data store. Data store is a service that allows developers to store semi-structured data. The service is designed to scale and optimize to quickly access data. Data store can be considered as a large object database in which to store objects that can be retrieved by a specified key. Okay, based on the key and the data, data can be fetched here. Both the type of key and the structure of the object can vary. So this is the main intention of keeping the data in a better manner. So you will be using data store for storing semi-structured data. So when you say it is a semi-structured data, the data will be fetched based on the key. With respect to traditional web applications, when you are using relational database, data store imposes less constraints on the regularity of the data, but at the same time does not implement some of the features, of the relational model. See, relational model is totally different from your semi-structured data. See, relational model is a structured data. So, but most of the applications require, web application require relational database management also. So in that case, data storage will not put a lot of restrictions. But anyway, it is again providing the facility for even relational database. But all of you know that data store is based on the concept of big data, which we have seen, a big table of Google, as we have seen in the previous chapter and previous section. So next is application services. Application services are the applications which are provided in the Google App Engine. The services or the provisions or the projects or the programs available in the App Engine can be accessed by anybody, and you can use it, and you can map it, you can share it. All these facilities can be made available through application services. Application services hosted on App Engine take the most from the services made available through runtime environment. These services simplify most of the common operations that are performed in web applications. Accessing data, you need to provide access to a particular user. Maybe some of you, sir, you did not get you did not give the access to the video of the previous lecture. I could not see, and I wanted to get it. So access permission need to be given. Some of your mails have come to me, and I need to open it, and then I have to give you access to your email ID so that you can access them. So account management, again, to which account we need to provide what type of facility. So in the Google Suite facility, some of the facilities provided for college account, some of them are not provided for a student account. See, these are all the things you can manage with account management. Integration of external resources, you can do it. Messaging and communication also. Suppose someone you are trying to access, you are trying to connect to this class, we need to admit you. Okay, so message comes here, there is a pop-up message for me, I'm trying to admit you. So messaging and communication is also there. Image manipulation, asynchronous computation. Asynchronous computation, at the same time, multiple locations you are trying to do computation. It's a asynchronous computation. When there is no dependency in computation, then you can go with the asynchronous computation. Otherwise, you need to go with a synchronous computation. Among them, these are some of the facilities: URL fetch, Memcache, mail and instant messaging, account management, and image manipulations. These are all the facility. Let us go further. So, yeah. What is meant by URL fetch? URL fetch is something like, you are trying to access the information through fetching the URL given. So Web 2.0 has introduced the concept of composite web applications. Okay, different resources are put together and organized as meshes within a single web page. You can easily, meshes are fragments of HTML generated in different ways. They can be directly opened from a remote server. They render from an XML document retrieved from a web service. So this is considered to be URL fetch. Next one, memory cache. Memcache. App Engine provides developers with access to a fast and reliable access to the storage. Okay, so that is your information here. You can access them. So Memcache is a facility for faster access of your memory. Faster access of your memory, which is this data storage. The data storage can be accessed, through Memcache facility. Mail and instant messaging, which I gave you an example now. So suppose once you have I have given you an invitation to this class, that invitation will go to your mailbox automatically, and once you accept that, that information will be written back to me saying that this candidate, this student has accepted your invitation for attending the class. That information. So mail instant messaging is also managed here. Account management. Okay, you have a web application often keeps various data that customizes the interaction that have with the users. These data normally goes under the name of user profile and are attached to an account. So you can have multiple accounts in your mobile phone. Also, you can see from you want to see in file in a particular drive. You want to move from that drive to another drive. You can easily manage your accounts. Just by clicking one click, you can log on to different accounts. That facility is provided using Google accounts, which all of you have seen. While configuring your mailbox through Google Gmail, you might have added one or two accounts in the same Gmail account. You can add Outlook account also in the Gmail account. You can add another Gmail account inside the same Gmail account. All that you can easily do it. That is Google Accounts, the very wonderful application which has been provided by Google, which you have already started using it. Okay. Next, image manipulation. Web applications render pages with graphics. Often it is required to perform simple operations such as add watermarks, and simple filters need to be applied on the image.Maybe you might have seen this. Let me give you an example. When you open your search engine, suppose you are trying to open image repository in Google search engine. Once you click on particular image, the image will not be visible in the first instance. After some time, it will be rendered and it will be cleared, and you can see a beautiful figure there. So you look at it. The procedure of sending your information, and if you are really interested to open it, then only it will access that information that available elsewhere. Otherwise, a blurred image will be displayed, and later the full content of the image will be displayed. So either you can think of it's a watermark, as well as simple filters will be applied to access any image, like image resizing will be done, image rotation will be done, image mirroring will be done, image enhancement will be done. All these are considered to be image manipulation. For this, Google provides image manipulation facility so that it can be used in your cloud operations. Next is compute services. Compute services for, as you know already, compute services for providing computational services. Maybe it's a platform as a service or an infrastructure as a service you can think of, where jobs can be executed. You need to provide infrastructure facility for execution, which we have seen high performance computing, high throughput computing, all that in the previous chapters. You can recall them here, how Google provides computing facility for bigger application execution. Web applications are mostly designed to interface applications with users by means of a ubiquitous channel, that is the web. Most of the interaction is performed synchronously. Users navigate the web pages and get instantaneous feedback in response to their actions. That is the normal behavior of a web server. This feedback is often the result of some computation happening on the web application, which implements the intended logic to serve the user request. App Engine offers additional services such as task queues and cron jobs that simplify the execution of computations that are off bandwidth, or those that cannot be performed within the time frame of the web request. So remember, all operations are performed through web. So you need to provide facility for accessing, sending information, getting the returned information, asking someone to execute your application and then get back the results. All these are being handled through computing services. So here we have two important aspects. One is task queues, another is cron jobs. What is a task queue? Task queues allows application to submit a task for later execution. So it is a scheduling of job. which we have discussed in chapter 8, how cron, how jobs are scheduled, how jobs are sent to queues, and queue will be managed to execute your applications. Okay. Next, cron jobs. Sometimes the length of computation might not be the primary reason, why an operation is not performed within the scope of the web request. Okay. So it might be possible that required operation is performed at a specific time of the day. Cron job facility. Suppose at 6 a.m. in the morning, your server need to be backed up. Suppose you write it, your facility to back up your database at particularly at 6 a.m. in the morning. Automatically that cron job will be executed and it will be backed up. All MySQL data will be backed up in your server. That can be done. Similarly, the cron jobs are also provided through web services. Okay. Next, we have application lifecycle. Application lifecycle. App Engine provides support for almost all the phases of characterizing the lifecycle of an application: testing and development, deployment, and monitoring. Okay. So App Engine provides a support for testing, for development, deployment, monitoring. Please note, testing and development. Actually, testing and development are repeatedly done, and then it will be deployed on the server, and then it will be monitored. All this is the life cycle of an application. So design is there. Before that, anyway, we have to make a design. Through the design, later we will develop, implement, and then test. Then deployment to the actual system, and then we need to monitor. So all these 4 operations are monitored as a life cycle of an application, and this is provided by App Engine. The SDKs released by Google provide developers with most of the functionalities required by these tasks. Currently, there are 2 SDKs available for development. One is Java SDK as well as Python SDK, Software Development Kit, Java Software Development Kit. Application development and testing. Developers can start building their web application and local development server. They will provide you. The facility is provided through Google Cloud Services. So that can be tested internally until it is deployed on a real machine. This is a self-contained environment that helps developers tune applications without uploading them to the App Engine. Now, as you know already, you have started using writing an application, Google application. You develop using your own local SDK facility, and then maybe Android builder, Android application developer, you can do it. Okay, there are multiple applications available where the IDEs are available. You can do it. So once these applications are developed and tested, then only it will be put onto the Google App Server or App Engine. Java SDK. We have a Java SDK. The facility available in Java SDK or Java 5 and Java 6 runtime environments available for development. Alternatively, it is possible to develop live applications within the Eclipse development environment. So not only Eclipse, so many other facilities are also there that can also use. Eclipse is very good application development environment. You can use them for development. Google App Engine, and there are various emulators available. For example, to run your application, before actually deploying into a real machine, a virtual box will be available. You can easily deploy your application on that virtual box, and then you can start working on that. Okay, and then once you are safe and you feel that the application is fail safe, and that can be posted onto the App Engine and anybody can access them. So which integrates the features of SDK within the powerful Eclipse environment. Python SDK. The Python SDK allows developing applications for App Engine with Python 2.5. Now 3.0 is already there. You can use the 3.0, 3.x Python SDK already available. It provides a suitable standalone tool called Google App Engine Launcher for managing web applications locally and deploying them into App Engine. Okay, so these are the facilities related to application development and testing. Next, we will move on to application deployment and management. See, once you have developed your application, that application need to be deployed on a real system, and then you need to test whether any problem is there before actually launching onto the public cloud. Once the application has been developed and tested, it can be deployed on App Engine with a simple click or command line tool. Before performing such tasks, it is necessary to create an application identifier which will be used to locate the application from the web browser by typing the address application.id.appspot.com. So that is the standard procedure to keep your application. Okay, it is also possible to map the application with a registered DNS domain name that is also available. This is particularly useful for commercial development where users want to make the application available through a more appropriate name. As you know already, see, once Google has given the App Engine, now Paytm also started mini app facility, mini app store. Mini app store is there in Paytm now. There was a quarrel between Google and Paytm. You know that. I think before pandemic, and maybe during pandemic, we saw this problem, and Paytm also has given a platform where companies can create their own applications and that can be put on the Paytm mini app platform, and then that can be used by anybody. That was there. Okay, just to understand the facility, what is the reality in development of applications. Similarly, Apple has got its own iCloud facility where App Store is available. Here we call it as App Engine. In Apple, they call it as Apple Store. So you just go to the Apple Store and you will get all the applications available. Here it is using a JDK, Java JDK, and Android platform, but here it is iOS platform. So just to give you the relations between iOS and Android. Cost model. App Engine provides a free service with limited quotas that get reset every 24 hours. Once the application has been tested and tuned for App Engine, it is possible to set up a billing account and obtain more allowance and change on a pay-per-use basis. This allows developers to identify the appropriate daily budget that they want to allocate for a given application. That you can quotas and per minute quotas, that like how you take your mobile phone facility, similarly app facility also can be got through Google. Google App Engine uses these quotas to ensure that users do not spend more than the allocated budget and that applications run without being influenced by each other from a performance point of view. There are some observations. What are the observations? App Engine, a framework for developing scalable web applications, leverages Google infrastructure. Yes, the core component of the service are a scalable and sandbox runtime environment for executing applications and a collection of services that implement most of the common features required for web development, and that helps developers build applications that are easy to scale. One of the characteristic elements of App Engine is the use of simple interfaces that allows applications to perform specific operations that are optimized and designed to scale. Okay, so these are the things which I wanted to discuss related to Google App Engine. Let me stop at this point of time. We can go to the question answering session. Then we will continue with Microsoft Azure in the next class. Thank you.